Thank you, everybody, for your attendance. So, along with Mr. Avgerinos, which is the facility manager of VIANEX Plant A, and his colleague Dimitrios Plotas, which is also in charge of operations, we are going to see our first results in the experimentation of creating one real GenAI application in the factory per se. So, Mr. Avgerinos, the floor is yours.
Okay, thank you very much. Good morning to everybody. I would like to thank the organizing team to accept our presence here and make this presentation of our work. I am a chemical engineer, so I have to speak for AI experts as a chemical engineer for manufacturing. It is like to change the game or to use the AI as a game. Here are some figures for my company, VIANEX. We are the first pharmaceutical company in Greece. It's a family company. We are the first in the numbers of sales with a market share of 8.5, and the second one is a multinational company with 4.5%. So we are the leader of the market, and the strategic decision of the top management is to use the digitalization in order to increase and grow the company. And we want to be in the first team, in the first pharmaceutical company in Europe. Now we are in the first 50 in Europe, and we want to rise in this index. A general slide. In this slide, you can see the AI contribution in pharmaceutical industry. So we have application, and we want to use AI in the drug discovery and development, personalized medicine, regulatory compliance, customer market insight, also for supply chain, employee training, predictive analytics, production optimization, quality control, data analysis, robotics, and energy efficiency. So you can see that we have the distribution in several points. Some are product-oriented, and some others are manufacturing-oriented. So here we will show you and present you an application related with the manufacturing-oriented. I think that we are the first company in Greece with such an application, and maybe one of the first in the world, using AI directly in manufacturing operations. The target is to use the AI and all the benefits from the AI in the industrial operations for the process optimization and also for the asset optimization. So we want to make such an application in all our operations and on all in our assets, in all of our plants, in order to increase and optimize our manufacturing processes. The path to the manufacturing excellence is a complicated history, let's say. So we have to standardize our procedures. We have to share our operational technology and all the data, collect everything, analyze data, monitor data, and all this in order to have the impact that you all understand. So this is a very chaotic system, and we want to use AI in all these fields in order to improve our work and finally to improve the efficiency of the company. So now we will go to the case study. I would like to mention that the challenge in this project is that we're a pharmaceutical company, and you have to remember that for pharmaceuticals, we are a very regulated sector, meaning that everything we have to do, we must fulfill all the requirements of the authorities and the authorities all over the world. So it is very important, the application we have, to validate it and be accepted by authorities. And also the second challenge was that we developed this application working only the last 3 months with our collaborator, which is the Ubitech. So I'll give the floor to my colleague, Mr. Dimitris Plotas, which is the operations manager of the site. Okay.
Thank you. For us, as Mr. Avierinos has already mentioned, the AI and technology is a driver to accelerate our path towards manufacturing excellence. And for this, very important is the knowledge management. We all understand that knowledge is a very crucial resource inside an organization. And it is behind everything. And we want AI and technology to help us increase the utilization of this resource, to make it for us more easier to access it and use it for our operations. Specifically, one specific area that knowledge plays a very important role is troubleshooting in manufacturing. Specifically, most of the time spent on troubleshooting, it's not due to the lack of knowledge, but rather because the knowledge is not stored and organized in a way that makes it readily accessible and easily applied to the field. In simple words, someone inside the organization knows what is a problem. Somewhere in a manual, in an SOP, there is a solution. The thing is how fast this solution will come to the field, and so how fast the problem will be solved, so how small the downtime of the machine will be.
Yes. At this point, we should shed some light about the model that has been created, and actually you are going to see a live demonstration of this platform. So, as Mr. Plotas said, and Mr. Avierinos, pharmaceutical companies are extremely regulated companies. To this end, there are really a lot of standard operating procedures regarding quality control, inspection, a lot of operational manuals, a lot of procedures, and of course, a lot of internal knowledge-based items that exist and can constitute the basis of a solidly found model that can be used directly in the field. We could say that from all these three sources have been taken under consideration. Of course, each source has its different ranking process, different chunking, different indexing, and of course, different utilization. In the sense that it was practically impossible to perform a one-size-fits-all embeddings model training and using the LLM in a uniform way. So that is to say that based on the type of the knowledge, in some aspects we apply graph ranking techniques, to try to extract named entity recognition based on some foundational minimal ontologies that we have created and exist there during indexing, during ranking, and during runtime. And this happens, for example, with the manuals, where the ecosystem is very fixed. So there is a production line, it has inspection equipment, it has photo shooting quality control cameras, labelers, etc., etc. So we could say it could be argued that a very minimal ontology of the production line has been created based on an interview and the input that was performed with VIANEX experts. And based on this upper model, the different sources have been indexed. And another peculiarity here is that it is maybe one of the first use cases that both the reasoner and the embeddings actually reside on-prem. And this is because of the regulatory framework, even the use of a public LLM completions API is not acceptable. That is to say that fine-tuned embedding models and LLM like Llama have been used for reasoning. And at the end of the day, we ended up in having a unified bot, which, based on the type of the query, a specific processing happens. And based on this query processing, we understand the type of knowledge, making both semantic search and vector search and ontology-assisted vector search, actually, in order to feed the context window that gives us the proper reply in very, very detailed technical questions that we are going to see right now. So please, Dimitri, the floor is yours to show some actual, this is the actual running use cases.
This is the use cases for problems that may occur during normal production. And until now, it was time-consuming to find the right manual or the right person because it is a complicated and advanced line from a technology standpoint. So here, in the left, you see the measurement of a checkware that measures a carton that we know that it is okay carton because we can check it in other ways, but the machine measures it incorrectly, so we have a lot of rejects without any reason, so the machine has stopped. Okay, so the answer is...
I think you should press.
Yes, okay. I said.
Okay. So the actual user submits the query in a physical language. It doesn't have to be very formal, as you can see, so it doesn't have to use the proper machinery or the type or thing. He just says, in my weight scaler, I have false positives or false negatives, and what should I do? Of course, manuals are not natively in Greek, okay, which is not preventing issue because all indexing and vectorization is happening with the NMPnet, with the multilingual sentence transformer, which is also fine-tuned based on the base knowledge. So here you can see, for example, that the virtual assistant that we have is actually giving some suggestions about what to give it a try regarding some specific, which is extremely, it doesn't lack precision, and it has a lot of semantic information that helps the production line manager to perform the proper corrective action.
And
so,
indeed, with these steps, already with step 2, the problem is fixed in a very quickly manner. Okay. Here we have another problem that the printing on the label is blurry, which is also a complicated matter, even if it seems simple, because it is an old printer with a lot of difficult how to interface, etc. So the question is very generic, just to imitate the operator, that the printing is...
Sorry for the Greek here. It's a system used by Greek users. It says that my labels are faintly printed.
Just this.
What should I do? Okay.
Okay. It gives all the right instructions. There are some parameters that you can change to fix this. And this is the result after increasing these parameters on the printer. This is another problem. This is from the same line that it is a use case. It is the incorrect apply of the label. It is a different device. It is the labeler. This is our knowledge know that it has to do with how it comes down to the blade, let's say in our language. So the user sees that this is a problem, but he doesn't know because it is where to go to fix this in the machine parameterization. So he asks, and the path is specific. If you could see also the machine interface, you would understand it is very specific, ALM, format, and you can fix. The same with the camera. As you can see in the left, there is an open case with products. We have a camera on top that sees every product is correct before the operator closes. This camera confirms that each one of these products is in the correct status. But when the operator says, OK, do it, I will close, the camera says some are missing. So here. So the green is not until the end. The label is not printed. The operation stops. When we see better why is this and is this happening, and we do a zoom, we see that the focus is not as good as it should be, and it cannot read everything. So, of course, we ask again.
Click one more.
OK, yes.
OK, so the question is that I'm using the matrix top view just to see the matrix, and I don't see a consistency that the entire box is correct. What's your saying on that? So the saying is by examining raw sources may be the focal aspect of the camera, so it might be the misplacement of the box or things like that. OK.
OK.
Which is in this case was the focal point of the camera.
OK. And as we can see, the focus is fixed, and the procedure now can continue.
Yeah.
And about the way forward and our...
Yes, OK.
Vision.
So as a closing remark, is that right now we have very solid results. We have already existing model, fine-tuned transformers, trained model, everything on-prem. We are continuously performing validation tests on the field with real users just to see the added value of this model. But the management's perspective is that we should go exhaustively till the end as far as the modernization and the LLM-aware production line is concerned. That is to say that right now there is a huge transformation project running in Facility A, which is one of the 4 facilities of the VIANEX, which has been appointed as the piloting facility, which is going to be totally indirectly interconnected with an LLM brain by installing in each sensor, actually interfacing with each bits and part of the production line. So right now, there is a sort of fragmented space where PLCs coexist, IoT sensors, instruments with multiple vendors. So the project that right now we are collaboratively running is to, first of all, create what we call the uniform data lake. So practically, with only one upper ontology and only one data lake that is continuously and real-time fed by the actual machinery that is deployed in Facility A, we will be able not only to perform QA, question answering usage of the bot, but to extend the bot in other flavors like action botting, analytics botting, so try to perform some actions, find some correlations, or draw some decisions. And to this end, all these modernization and data laking aspects have to be confronted. And this is what we are actively doing now. So we are working in 2 threads. We performed the LLM-enabled, let's say, help desk for the operator. And now we are running the huge project, which is modernizing and taking data sets from the entire product line and trying to explore and exhaust the merits of the generative AI in an interconnected environment with all data set. And we hope in the next GenAI conference to show the outcome of these efforts too. So this is the, I think our time is up also. So thank you very much. We are here for any question or...